Hi everyone, today we're doing lesson 5.2a, direct variation. Our goals today are to recognize a directly proportional relationship, write a direct variation equation, y equals kx, and graph a direct variation equation. A direct variation is a specific linear equation, so it is linear. It's going to make a straight line where there's a constant ratio between the ordered pairs. Let's look at that. So I have a situation here. It looks like you were texting a lot over the summer. This is the number of hours, number of texts you sent out. Here's our table. So 0 hours, 0 text, 1 hour, 45 text, 2 hours, 90 text, 3 hours, 135. That looks like it was changed. 4 hours, 180. Now let's look at this y over x pattern. I'm not talking in this case change in y over change in x. I'm saying y over x. I'm not going to do 0 over 0, but I'm going to start with 45 over 1. That's my first ordered pair. My first ordered pair is 1 and 45. If I looked at it this way, that would be my ordered pair. 45 divided by 1 equals 45. Let's look at my second one, 90 and 2. Well, 90 over 2 equals 45. If I did 135 over 3, I would get 45. 180 over 4, I would get 45. In other words, I can look straight across this table. I am taking x and I'm multiplying it by 45 every time. So my equation for this is y, my number of texts, equals 45 times x, my number of hours. There's nothing added on. It's not a plus anything. It's just y equals 45x. So this is my y equals kx. The k in this case is my slope. Why is k slope in this case? I have no idea why they give it the letter k, but they do. So y equals kx for a direct variation. This is my slope. I could do my change in y. This is 45 over 1. 45 over 1. Now if I were to graph this, I already did all that, sorry. It would look like this. And it would be a straight line, 145, 290, 3, 135, 4, 180, beautiful. But it will go through 0, 0, and that's important. If you have a direct variation, linear equation is direct variation, it will always go through 0, 0, which means it's starting at 0. That's why we have the plus 0 or nothing here. Let's look at my next example. Here's my table. Let's look at my y over x pattern. I have 6 over 3. I have 10 over 5. 14 over 7. 18 over 9. And if you look at those, you'll see that these are all equal to 2. So my y over x pattern is 2. If I calculate my slope this way, I would have 4 and 2. And we know that 4 over 2 equals 2. So my equation for this is y equals 2x. You can see that looking across the table. 3 times 2, 6. 5 times 2, 10. 7 times 2, 14. 9 times 2 is 18. So my graph in this case would look like this. And again, it goes through 0, 0. That's how we know we have a direct variation. It goes through 0, 0. Let's look at my next example. This one might not look quite as obvious to you, but let's look at our x over y values. I have 6 over 4. I have 9 over 6. Fifteen over 10. And lastly, 18 over 12. I could simplify each and every one of these, and if I do, I will end up with 3 over 2. They're all equal to 3 over 2. So if I graph this, it would look like this, and I would notice that it goes through 0, 0. You can see if I went up 3 over 2, I'm here. That's on my line. Up 3 over 2, up 3 over 2. This is counted by 3's on my y-axis and 2's on my x. So I could also use my table. This is up 3. This is up 2. So my change in y is 3. My change in x is 2. So 3 over 2. Remember, that only works when you have a direct variation, when it starts at 0, 0. Now let's try this one. Do it on your own, stop the video, then come back and see if you got the same thing. So you can see my pattern for this one is 1 over negative 4. Two over negative 8. Three over negative 12. Now typically when we simplify, we like to just put a negative up front, then you have a positive and a negative, and this would all simplify to negative 1/4. So negative 1/4 x. If I graphed it, it would look like this. It's a negative slope, so it's going downhill, and it will again go through that 0, 0. If you wanted to check your slope, this is going up by 1, and this is going down by 4. So 1 over negative 4, which is same as negative 1/4. You can use a table or a graph to find the slope. This one's a little harder to use a graph, I would say. I did not clear my screen. So, just drawing conclusions. For a table, if you can look directly across the table to figure out what you can multiply x by to get y, you have a direct variation. All y over x patterns will be proportionate, which means that they will be equal fractions. Your y over x pattern is your slope, and we're going to call that k for direct variations. And the graphs are linear and they will always go through 0, 0. That's it. Have a great day.